The invention of the web dates to 1990, when physicist Tim Berners-Lee at the CERN particle accelerator in Switzerland created a set of technologies to allow combining text, graphics, and most importantly, hyperlinks within the same document. The idea for doing this using modern technology had been around since at least 1943, originally outlined in a now famous article called As We May Think, written by Vannevar Bush, an electrical engineer and scientific advisor to the US government during World War II. But it wasn't until decades later that computing technology was mature enough to implement those ideas in a way that could have wide impact. The software developed by Tim Berners-Lee and his colleagues was revolutionary, and in 2016, he received the Turing Award in recognition of his pioneering work. But for the first few years, the World Wide Web, as he called it, was practically unknown outside the academic and scientific communities. In 1993, though, a group of programmers at the University of Illinois created Mosaic, the first graphical web browser that non-experts could easily install and use on consumer PCs. Within a year, NETSCAPE Communications had been founded as a startup to commercialize the browser, and NETSCAPE quickly became the most important company in making the web a mass-market phenomenon. In 1995, PC users thought it was pretty revolutionary to seamlessly combine text and graphics on the same page and to follow hyperlinks to related pages anywhere on the web. But early web pages were pretty boring by today's standards. Text, graphics, and fill-in forms were about all you got. So NETSCAPE decided to change all that by providing a way to write code that could manipulate content on a page after the browser had loaded it, allowing pages to include much richer interactive elements. But what language would they choose for providing this capability? Brendan Eich, the creator of JavaScript, initially wanted to use Scheme, a dialect of the venerable Lisp programming language, because of its elegance. On the other hand, NETSCAPE had just solidified a business relationship with Sun Microsystems to promote its new Java programming language, so Eich was being pressured to use Java as the browser's language instead. In the end, Eich and NETSCAPE founder Marc Andreessen, along with legendary Sun Microsystems software engineer Bill Joy, agreed that the browser needed a language that was more approachable by beginners, analogous to why the BASIC programming language had been invented in 1964. There was only one problem. The so-called browser wars between NETSCAPE and Microsoft were heating up, and NETSCAPE wanted to release their new in-browser programming language with the next release of their browser, which gave Brendan Eich just 10 days to design and implement the core of JavaScript. As you can imagine, such a hurried design means that the language is not without problems. But it's remarkable how quickly it grew from a language designed to enhance static web pages to a language that could create single-page apps like Google Docs using AJAX, or asynchronous JavaScript and XML, a technology first introduced in Microsoft Internet Explorer. In this module, you'll learn about the special relationship between JavaScript and the browser, and you'll approach JavaScript, the jQuery framework, and AJAX using the same strategies we used earlier to learn Ruby and Rails. Just as Rails takes advantage of specific Ruby features, JavaScript's asynchronous programming model, in which an app can initiate a long-running operation and specify a callback function to be invoked later when the operation completes, is a great match for creating an interactive user experience in a web browser. Along the way, you'll encounter some of the tools and techniques that developers have created to manage the complexity of today's JavaScript apps, including how to test both JavaScript-based user interfaces and AJAX functionality. While new JavaScript frameworks seem to appear every few months, if you understand the basic ideas of how JavaScript interacts with the browser and how its asynchronous, event-based programming model works, you'll be in a good position to learn any new framework rapidly. And that's what keeps great software engineers in demand.